Good day, friends and students. Welcome to yet another episode of our tutorial classes on Prep Station. And on this session, we'll be looking at the topic projectile motion. What is projectile motion? This is the motion of an object along a parabolic path. Example, a stone that is thrown into the air from a catapult goes in the air, takes parabolic motion before it returns to the ground. That can be said to be projectile motion. Now, if you look at the diagram that is shown here, you can see it's a diagram of a stone that being projected into the air. It gets to its maximum height, then finally it begins to descend. So, if you know from the point of projection, the time is equal to 0, while u, which is your initial velocity, can be resolved with respect to the vertical component and as well the horizontal component. So if you look at this diagram, if you want to resolve u, which is your initial velocity, with respect to the horizontal component, you are going to have it as u cos theta, while along the vertical component, you're going to have it as u sin theta. Now, let's take a look at the few formulas that are required in projectile motion. Now, take the time it gets to its maximum height, which is usually the time it takes from the launch to get to the maximum height, which is usually the time. And it's giving us u sin theta all over g. Now, the total time it takes from the maximum height back when it returns back to the horizontal plane also is another thing. So if you notice, the big T is usually known as the time of flight. So the time of flight is usually given as 2u sin theta over g. Now, let us look at the height, the maximum height from which the stone can be projected, which is usually given as h. So h is usually given as u squared sin theta over 2g, while your horizontal range, which is the maximum displacement from its original point of projection, which is given as r is usually u squared sin 2 theta over g. So it is good for us to acquaint ourselves with these simple formulas in order to be able to solve questions under projectile motion. Now, having gone through these formulas, let us see how we can apply this formula to the questions that come out during our UTME exam. Example, let's look at this question. An object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The question now is, calculate the maximum height that is reached. So now, from the formula that was given before, we notice that our maximum height h is u sine square theta all over 2g. Now let's bring out the parameters that are inside this question. We have our angle of projection at 30 degrees. Then we have g, which is acceleration due to gravity, 10 meters per second. And then we have u, which is our initial velocity as 80 meters per second. Now, let us plug all these parameters into our equation and see what answer we are going to come out with. So we are going to have our initial velocity, which is 80 meters squared, multiplied by the sine square of theta, which is 30 degrees. That means sine theta times sine 30 multiplied by sine 30. And the value of sine 30 is 0.5. So 0.5 multiplied by 0.5, everything is going to be divided by 2g. 2 multiplied by 10, which will be 20. So if you have 6,400 multiplied by 0.5 multiplied by 0.5, you are going to have 1,600 divided by 20, which will give you 80 meters. Now let's go to the options that we have in the question. A says 20 meters, B says 80 meters, while C says 160 meters, while D says 320 meters. So from this question, we can see that option B is the correct answer to this question. Now, let's still take another question. Now, the question reads, an object is projected from a height of 80 meters above the ground with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. What is the time of flight? What is the time of flight? Now, the time of flight. So from here, we can see that the height that is given is what? Is 80 meters, u is 40 meters per second, and theta is equals to 30 degrees. So now, if we look at the question correctly, we can see that t is usually u sine theta over g. Now, what is our u? The u there is equals to 80 meters per second, while our theta is 30 degrees. So if we plug that in, we are going to have 80 multiplied by sine 30 divided by 10. So 80 times 50, that is 40. So if you look at the answer there, we have 40 divided by 10, which is 10 seconds. But since it's time of flight, we are going to multiply by 2, which will give us 8 seconds. So the correct option here is going to be 8 seconds, which is what? D.